In this video, we're going to look at finding the first and second derivative of some standard functions. So the first example, we're being asked to find the first derivative dy dx of the functions. So the first one is a is 3x squared, and the second one b, y is 2 over x cubed, and the third one c, y is 1 over the square root of x. And we'll just look at each of those now. And the first one, in all of these examples, we will be using we have y in the form maybe a x to the power of n, and the first derivative y dash, or dy dx, I'll just call it y dash, equals n times a to the power of x. N times a x to the power of n minus 1. A is some constant, and a and n are constants. So for each of those, we'll use this formula. So in the first case, we've got y equals 3x squared. So dy dx, first derivative, or y dash, equals 2 times 3 is 6x to the power of 1. The second example, we have b. Y equals 2 over x cubed. Now, to use the formula that I've noted above, we do need to change the form of y. So rewrite y in such a way that we can apply that formula. So using our rules of powers, y equals 2x to the minus 3, which means y dash, or the first derivative, dy dx, is going to be negative 6, that's negative 3 times 2, x to the power of negative 4. Now we can leave it like that, or we could revert to using the rules of powers to say negative 6 over x to the power of 4, but we don't need to further simplify. The final example in this first question was y equals 1 over the square root of x. Now again, we have to write this in power form, which we know is 1 over x to the power of a half. Now in order to use the formula, we will use the y equals x to the power of minus a half. And now we're ready to find the first derivative. So dy dx, take the power down, minus a half, times x. Now we've minus a half minus 1, which will give us minus 2 over 3. That's that's minus 3 over 2. What am I saying? So we've minus a half minus 1 is minus 3 over 2. And that answer is fine like that. We don't need to do anything further. We can look at some other examples now. In the next example, we're going to find the first and the second derivative of the following functions. So a is 3x squared plus 2 minus 1. And b is ln x, and c is y equals e to the 3x. So let's have a look at these examples. So we'll take them one at a time. So the first one we were given was the function y equals 3x squared plus 2x minus 1. And we find the first derivative using the formula we did previously. We've got 6x to the power 1 plus 2. And the final term goes to 0. So that's dy dx. Now the second derivative, we simply differentiate again. So d2y dx squared equals 6. So that's the first example. The second example B, we were given y equals ln x. So we know from our formula book that dy dx, first derivative, equals 1 over x. So it's a special case that's in the formula book. Now if we want to get to the 2y dx squared, the second derivative, we need to rewrite the dy dx in the form where we can use the power rule. x to the power of minus 1. So the second derivative, d2y dx squared, is minus 1 times x to the power of minus 2. We can simply rewrite that as minus 1 over x squared. We don't need to rewrite it, but that is it simplified. The last example we were looking at was C. We were given y equals e to the power of 3x. Now again, this is a function that's in our formula book. So dy dx equals 3 times e to the power of 3x, which means the second derivative, d2y dx squared, equals second derivative d2y dx squared equals 9. That's 3 times 3 e to the 3x, and that's the example C. So we just have one more to do in this video, and we'll take a look at example 3. Find the second derivative of the following function when x equals 0.5. We've got y equals sine x plus ln 2x. So I'm going to take a look at that one. The second derivative, so we're looking to find d2y dx squared when x equals 0.5, and the function y was given as sine x plus ln 2x. So first of all, we'll find the first derivative, dy dx. Now from the formula book, the first derivative of sine x is cosine x. Now be careful here, this is ln 2x. We could actually say ln 2x, I'll just go across here, ln 2x equals ln 2 plus ln x. We know that from our rules of logarithms. So dy dx of ln 2 is 0. 0 plus 1 over x. So ln, the first derivative of ln 2x is just 1 over x. The second derivative, well, let's just write the first derivative out again. First derivative is cosine x plus x to the power of minus 1. So the second derivative, d2y dx squared, equals, now cosine x goes to minus sine x, and the first derivative of x to the minus 1 is minus x to the minus 2. So we need to find the second derivative when x equals 0.5. So I'll take my calculator for this particular calculation, and we have to be careful. We've got a mixture of algebra and trigonometry, so we do need to set the calculator to radians. So we're going to assume that 0.5 is a degree, is a measure of radians. So we're on or for radians. So we're going to say sine 0.5. I noticed I need to do negative sine 0.5 minus 0.5 raised to the power of minus 2. And the answer we get is 4.479. So let's say three significant figures will be negative 4.48, minus 4.48, 0.48. That's correct to 3SF. And that's it for this video. So thank you for watching.